As an Englishman living in the UK, I can say with utmost certainty that rainfall is one of our biggest enemies. It can strike at any time of the year, from a cool summer evening to what was forecast to be a crisp, dry winter afternoon. It's a sad reality, but back in 1978, us, Brits, were handed a new weapon in the battle against wet weather. It was called Goretex. We all know that Goretex keeps us dry, but do we know what Goretex really is? Is it a fabric? Is it a spray treatment? It's been 40 years since this cornerstone of performance fabrics entered the market. So let's take a closer look at Goretex and why we are willing to shell out an extra $100 on a ski jacket that has it.
In the quest to clarify what it really is, let's first clear up what Goretex is not. It is not a fabric or a textile. It's not a weave. It's not a boots, jacket, glove, or hat. In fact, it is not any piece of apparel or equipment. Alright then, so what exactly is Goretex? It is a brand and also a coating or a chemical treatment that is applied to clothes, shoes, medical appliances, electrical conducting wires. Goretex is a laminate containing layers of the polymer nylon, PTFE, and polyurethane. And the PTFE layer is the key component that provides unique features of a Goretex garment. To be even more accurate, it is the ePTFE that makes Goretex more special. ePTFE is an expanded polytetrafluoroethylene membranes, which is literally a material that is created by expanding PTFE, creating a microporous structures with very desirable characteristics. The expansion requires heated PTFE anywhere from 350 to 320 degrees Celsius while keeping it restrained in a device capable of stretching it at high rates. This expanded PTFE layer contains millions of tiny holes called pores per square millimeter. The pores are 20,000 times smaller than water droplets, but individual water molecules are 700 times smaller than pore. So, water molecule can pass through the pores, but not water droplets. For example, rain. The intermolecular bonding forces between water molecules are hydrogen bonding, which is quite strong, and water droplets like to stay intact due to these attractive forces rather than adhering to the hydrophobic PTFE layer. It is the tiny holes in the PTFE layer that lets individual water vapor molecules, such as our sweat, to escape through the micropores, but rainwater can't get into it. This feature of an expanded PTFE makes outdoor clothes laminated with Goretex to be extremely comfortable to wear, since our sweat can evaporate through these pores, but it protects us from rain.
This is a simple diagram of how Goretex is used in outdoor clothing. So there are protective layers in the outside such as nylon or polyester that protects the Goretex membrane, and inner layers such as thinsulate used as an insulator to keep your body warm and dry.
You must have realized that Goretex has a close link to ePTFE, or PTFE, which is known as Teflon for us. So now I would like to talk about the chemical properties of PTFE that makes it a perfect material to create these outdoor fabrics. And to do so, we should first address the question why these PTFEs are hydrophobic rather than hydrophilic. If you paid some attention in your chemistry lessons, I'm talking to you, Joey, You must be aware that nonpolar molecules that repel the water molecules are said to be hydrophobic. On the other hand, molecules forming ionic or a hydrogen bond with the water molecules are said to be hydrophilic. So polar molecules dissolve easily in water, while non-polar molecules does not. It's mostly about the polarity of the molecules. And so I initially looked at the structure of the PTFE and thought that it should be hydrophilic because PTFE has fluoride atoms attached to the carbon chain, and therefore due to the electronegativity of fluoride atoms, it should interact with water molecules by forming hydrogen bonds, making it hydrophilic. But in reality, PTFEs are known to be hydrophobic. So I thought for a while and eventually realized the bonding structure of PTFE made it to be nonpolar. If you recall what we learned in topic 4 of IB chemistry, carbon tetrafluoride had a net dipole moment of 0, despite the CF bond definitely showed a polarity. The reason was because the pyramidal structure of the tetrafluorides made the molecular shape to be symmetrical, and the dipole moments were cancelled out. I believe that the same thing happens here as well. Indeed, fluoroatoms do have high electronegativity, but because of its symmetrical structure, it is a nonpolar molecule, and thus it is hydrophobic. It's getting hot now. I'll take this off. And also, one of the reasons why Goretex or PTFEs are used for outdoor gears and medical appliances is because it is resistant to chemical reactions, and you can use it for an extended period of time. For PTFE, the only two bond types present in the structure are carbon-carbon bond and carbon-fluoride bond. Both of these are very stable bonds that are difficult to break. A break in the bonds can allow chemical reactions to occur. In fact, the CF bond is one of the strongest found in polymers. This leads to the exceptional chemical resistance for PTFE. As you've learned in class, CF bonds are strong because the electron density is concentrated around the fluorine, leaving the carbon relatively electron poor, and the massive electronegativity difference causes fluorine to form a strong single bond to carbon. According to my research, carbon-fluorine bonds can have a bond association energy of up to 544 kilojoules per mole, and that is the strongest bond that carbon can form. And another factor that we must put into consideration is the packing of the polymer chain. The long polymer chains of PTFE are not flat and straight, but it has a zigzag shape. And to fit the molecular structure into the available space, the PTF chain is forced into a spiral shape with fluorine atoms packed tightly around the central carbon-carbon bonds. These fluorine atoms then provide a protective sheath for the weaker carbon-carbon bonds, and the result is the extremely strong chemical resistance of the PTFE.
Those two properties of PTFE has inspired Robert Gore, the founder of the Goretex company, to come up with such revolutionary invention. However, Goretex carries a lot of environmental and health issues as well. According to the Goretex corporate website, the PTFE polymer, which is used to make the ePTFE membrane, is non-toxic, biocompatible, non-soluble, so it will not end up in water or oceans, and it does not degrade to become perfluorinated chemicals such as PFC. Also, they've claimed that environmental impacts due to the manufacturing of the ePTFE membrane are countered by the extension of the lifespan and performance of the products they are used in, therefore balancing the environmental impact of production. So based on the Goretex website, Goretex clothing seems to be quite environmentally friendly. But we should remember that the water repellency of the jackets and clothes are due to the DWR treatment, or the durable water repellency treatment made from the PFCs, or the perfluorinated chemicals. And as the Guardian News have reported a few years ago, almost every single high-performance fabrics are coated with PFCs. It mentions that previous studies in both animals and peoples have showed that PFCs causes various health problems, such as liver toxicity, developmental changes, immune system alterations, and various types of cancers. So PFCs carries a significant health threat, and we should avoid the use of PFCs in our real life. Now, to end the video, I'd like to share a brief message with you guys. Mr. Gore was a true genius with a creative mindset who identified that PTFEs can be applied in clothes, electric wires, and even medical appliances. The application of chemistry in real life and the experimentation that he undertook during his lifetime is something that we must learn from him. But we should not forget that overuse of Goretex products can damage our environment. I won't say that we should boycott these products, but for sure, we should not overconsume these Goretex products, and we must use it for a long period of time to mitigate the environmental impact of the production. Thank you very much.